No, 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 you are very partial. He kept quiet. Then next day when he was teaching, he told the knowledge should be something like an arrow which goes through the water but doesn't get wet. It should be like that. Then immediately he was, everyone was surprised. They said, how can you have an arrow in the water without getting wet? Then he said, when the time comes, I will prove. 3 4 weeks passed. Suddenly one day Arjuna was called by Dronacharya along with Ashwadhama, and he was told that you have to carry water in your palms, in your hand like this, go to the other part of the hillock and wet the land there. Then everyone thought, how can this happen? And of course, very sincerely, the two young boys, they started doing, they could not. After 10 times Ashwadhama gave up, but Arjuna thought for a while there should be some reason for Guru to give such a task. He looked up, he saw one big honeycomb. So he shot the honeycomb and honey started falling down. The honeybees were biting him, but still he has wet his palms and palms got stuck to each other. It became like a small bowl. He collected water in that bowl of hands and he went to the other side of the hillock to wet the entire land. Then, meanwhile, a lot of bees have bitten him, and Guru came back. He saw Arjuna quite badly bitten by the bees, but the land was wet. He asked Arjuna that how did you do it? Then he said, Sir, I remember your words that the knowledge should take us like the arrow in the water which doesn't get wet by itself. Then I thought there should be some reason. That means that when we are going very focused, what is happening around us should not bother us. Number one is that. Number two is that we should also use the accuracy of the arrow. My accuracy of arrow is to use my knowledge to make my palms look like a bowl, and my behavior as the arrow is that even if the bees bite me, I have to complete my task. Mathematics teaches these two skills, the accuracy and the logic, and traveling point to point without turning here and there. And we have got a very eminent personality amongst us who can take us through this journey of actually learning mathematics in a most interesting way. And she has got the very, very interesting biodata. I'm so thrilled that I'm given this opportunity to introduce her. She is the head of mathematics in from Sanskriti School, New Delhi, a teacher of mathematics for the last 30 years, and she has been teaching students of grade 11 and 12. Recipient of National Award for using ICT for innovation in teaching in year 2016, a Google Education Certified Innovator and Trainer, and she is also a Fulbright Scholar. She was awarded Fulbright Distinguished Award in Teaching in 2011. Sangeeta has the distinction of being associated with NCERT for last 25 years for development of e-contents, including video lectures on mathematics for senior secondary classes. She has presented more than 125 video lectures on mathematics in CIET and CERT Studio, along with development of scripts. An enthusiastic user of technology, Sangeeta has empowered hundreds of teachers of India by conducting workshops in GeoGebra, Desmos, Google Suite for Education, and other online resources. Ladies and gentlemen, we are very, very privileged to have such an eminent mathematicians amongst us. You can actually join your hands in welcoming Mrs. Sangeeta to give us all a complete, a thorough insight into knowing what is GeoGebra is. Ma'am, over to you. Thank you for being here.
Thank you. Thank you so much for such kind words. And it's such a pleasure to be able to join all of you. I know you've all been very actively bringing the professional development opportunities for teachers. And so I'm very privileged that I have got this opportunity. Thanks to Vasanti ma'am for inviting me to be here with all of you. So I cannot express how happy I am and how thrilled I am that we don't have to travel anymore. And sitting at our own houses, we are able to interact and meet each other. I think that is the opportunity that this pandemic has brought to us, and we are all utilizing this opportunity to make full use of the possible use of technology to reach out and to share. And today it's my privilege to be able to share some of my learnings. And again, as you cited, the achievements that I have are more for me in terms of my passion. So I started exploring the use of technology sometime in 2008 or 9. And then in 2011, with the Fulbright program, I got a little bit of a time to work on what I really wanted to do. And from then onwards, it's been a journey which has helped me to explore and learn more. And with each learning, I also look forward to these opportunities to share with educators, because it is very important that I'm not the only one who's teaching, right? Teachers all across are using and are in need of using different tools. So here I am to share two important tools of maths, which I very strongly believe in and I love to use. So I'm going to just share my screen so that we can have a reference point as to what I'm talking about. And hopefully you can just confirm if you are able to see my screen coming up.
Yes.
Yeah. So I'm here to talk about GeoGebra and Desmos. So I hope if somebody can confirm, yes, is the screen visible?
Yes,
Okay.
yes, it is
Yeah,
visible.
great. Thanks. So as was mentioned, I am Google certified trainer. So I love to use G Suite for education. But for maths, there are specific tools that one must learn and use, which can be integrated with G Suite if required. But today we are not going to be talking about G Suite. We'll be talking about purely what GeoGebra is and how do you use it to, as my title is of the session is to create, to visualize, and also to explore the mathematical concepts. So how does one use the power of technology in the form of two main tools, GeoGebra and Desmos, to give our students a chance to create and learn maths. It's not only reading or memorizing the results, but what if they are able to also visualize these abstract results? What would be possible if they are able to create some geometric constructions, dynamic results, and then they are able to explore those geometric results. So that is the part that the technology brings with it, and that is what we are here to explore. So I hope, as I had requested earlier with the organizers, it would have been great if you are sitting on a laptop, because this is not going to be just a lecture. I would like you to participate, but for me to just to get to know who all are in this meeting today, who are the people that I'm talking to. It would help if you could just open a new tab and put in www.menti.com. I'm sure you've been using Mentimeter in your work and in your teaching as well. If not, it's a great tool to use. But just to sense who I am addressing right now, it would really help me if you can open up menti.com. It will ask you for a code. No logins needed. It will ask you for a code. So just put in a code 122420 so that I can understand if you are here, if you are a maths teacher, then which class are you teaching? Also to understand, because we are all in the remote learning and remote teaching scenario, what kind of maybe struggles you've had. Is there a way that as a maths teacher, because I've been meeting maths teachers, all across since March, in fact, I've been interacting with teachers all across India, and the struggle seems to be common. Everybody seems to have a common struggle, especially maths teachers have a very peculiar struggle of how do we write maths on the board. Well, yes, I'm not actually going to give you a solution for that. I can suggest few things at the end, but not really that. But otherwise, other than writing maths on the board, what are your other struggles going to come in? So let's talk about few things like that before we get on. So just join in with the code I have shown you. I'll again show you the code. So go to menti.com and use the code 122420. And I can see 16 of you have kindly clicked on and you are responding to it, that these are your main struggles in teaching remotely. So geometry seems to be the struggle, assessment, yes, interaction and maybe the lack of interaction that we have with our student. That could be your struggle. Abstract questions, introduction to algebraic. Well, yes, just write one word. That would be helpful. Just keep your answers to one word. So there are two boxes there. It would be nice to see that. Okay, so what you're looking at here is there are three words that are coming up, or maybe four, that are taking the show over. One of them is assessment. So definitely most of us perhaps are struggling with the assessment. How do you assess your students? How do you get to see their work? I also see that your concerns are about geometry. How do the children learn geometry? How do you teach geometry? Also constructions, yes, absolutely. But geometry seems to be leading the show here. Well, thank you. So I can see the audience is very participative, and thank you so much. So let's move on to just trying to understand who all are here. The code will still show up, but I'm just moving ahead to the next page to see what is going to happen here. Let me see if I can navigate that. All right, just to again understand, out of all of you that are here, which level do you teach? So let me just have an understanding of the kind of audience I have so that I can share the session accordingly. I can mold the talk accordingly, and maybe the activities that we do will be focused more for that class. Okay. So I see there are majority of you are in the bracket of 6 to 10. Oh, great. That gives me some idea of what I'm doing. Thank you so much. So I can see 181. I have never had such an enthusiastic participation. Wherever I have gone, they hesitate to answer. But yes, thank you. That is fantastic. Well, 200 plus answers coming up. Good. So I have a fair idea. So let's talk about this. How familiar are you with GeoGebra? Because GeoGebra is one of the world's famous and most used tool. It is kind of has revolutionized how maths is taught and learned all across the world, and it's been around for more than 15 years now. So it's not a new tool. It's been around for more than that I can remember. But and it is a free open source, as I will introduce more features of that. But I can see that there is a whole lot of you who have not used, or you are not familiar with GeoGebra. Okay, that's perfect. So that makes this session a little more specific for me. I know now who I'm talking to, and how it is. And I can see some of you have used GeoGebra a few times. And then there are some regular users as well. And of course, I also see some expert users. So that is fantastic. And I hope there will be something for everyone in this session, but I will try to target the bigger slice of this cake, and try to target so that everybody gets to learn from the same level, and then you take it onwards wherever it is going. Great. Thank you so much. So once you have that in place, let's talk about then what exactly we are going to be talking about, and why should we be using a tool like GeoGebra, or as the talk has given you an indication, something called as Desmos. I didn't ask how many of you know Desmos, but if you do, great. If you don't, well, you should have something very interesting coming up. So when I think about technology and maths put together, I kind of like to use an equation like this. So I say technology plus maths is equal to X. So most of our maths goes with find X. But here this X for me is going to be that X factor that gets added in when you mix technology in the maths teaching and learning. So the X factor that I'm looking at here in this case is with the use of technology. When you're teaching maths, it brings in clarity in the teaching. So the lessons become more clear for you, in fact, as a teacher, as well as for your students. It also brings in that little bit of a fun element. It's always needed. You can't have maths or any class boring, because you want students to listen to you and also get engaged in their learning. So when you add technology to maths, well, it's going to surely bring a lot of engagement. invent any kind of technology, like right now that Mentimeter that we did, we got you all engaged, right? So anything like that, but when it is with a specific purpose of teaching and learning, when you are looking at getting ourselves to learn some tool or some concept, definitely it helps. And again, active learning, when we want students to be engaged, it will make sure that they are actively involved in their learning. Visualizations, so maths is all about concepts which sometimes can become very abstract. Sometimes the idea that is clear in your head doesn't get transferred to the student because he is not able to see the same thing as you are talking about. So when you use technology and a tool, definitely the visualization is very, very important. And also I would like to say that those special aha moments, that sudden bulb that lights up and says, okay, that's what this is. So that is what technology does. So when you use the right tool and use the right pedagogy, of course, then you are allowing students to learn in all these ways and make them accept and marvel at the simple concept which was sounding so complicated to them. So especially when we look at higher classes, it definitely is going to be more and more complicated for them. There are a lot of tools, and now I think in the past 3 months, each one of you, even the one who had never ever used technology, has gone ahead and made use of many of these tools, and they all fit in very well with the math teaching as well. So if you are a Khan Academy fan, then definitely you know what it is. If you want to bring some kind of a gamification in the way you do the assessment, then Kahoot and quizzes are two ways of looking at it. If you are using videos in your classrooms, then using Edpuzzle, which turns the videos into lessons, is the way to go. So I'm sure many of you are familiar with that. G Suite for Education blends in very well with maths in all possible ways. But the other two that you are seeing here, these are what we are focusing on today's session. And the first one is GeoGebra. So this is the icon for GeoGebra. And then we are going to also spend, say, half an hour on Desmos. And Desmos, again, when we think about it, has multiple possibilities, and we'll explore them as we go along. I don't want to give out the entire explanation in the introductory slides. So let's just focus on first GeoGebra, and then we will come to the other things. So since I saw many of you who said that you are not at all familiar with GeoGebra, it would be good to just have a brief understanding before we get on to the hands-on experience of it, what exactly GeoGebra is. So it's first of all, it's a dynamic mathematics software. So when we say dynamic mathematics software, it is something where when we create something, we can drag and change the sizes, move the points, change the size of the circle perhaps, but the shape would remain, the geometry properties would remain there. So you're looking at all of them behaving in a way that the construction has been done, that the applet retains the mathematical property. So we are looking at that to be the dynamic mathematics software, and it is suitable for all levels of education. So brings together geometry, algebra, even spreadsheets, graphing. You can have statistics, calculus, all in one ready to easy to use package. And along with that, the idea is that you can use this in many ways. It can be a show and tell, or it can be something which the child is able to explore. And when you give chance to students to explore, then basically you're looking at giving them a chance to look at how they explore these results to make certain conjectures. So when they make certain conjectures, then they explore and they understand the maths that is coming in. Beauty of GeoGebra is that it is an open source software, which basically means that you can download it. If you don't want to work online, you can download it. It comes in different apps as well as per your device. You can have a combined software which I had recommended, GeoGebra Classic 5, which is perhaps what I will use to demonstrate today. So if you have downloaded it, good. If you have not downloaded it, then I would advise you to go to www.geogebra.org and install this software so that you can join me as we explore. Also, the same software, the power of the software is equally available as a mobile app. So you can have different apps for geometry, graphing, 3D, even an augmented reality, which goes with the 3D, coming in use when you are thinking of a mobile app. So you can go to your Play Store and then download if you wish to do that. But when we start talking about it, or when I start doing it, there are certain features which are different when you're working on a mobile and then when you are working on a bigger device. So I would advise you to use a bigger device right now if you are doing it, or if you're a beginner, then you must use a bigger device, and later you can also explore it on your phone. So again, what does GeoGebra do? So as you can see on the slides coming up, my way of saying what GeoGebra do is to say that maths comes alive with GeoGebra. So as you can see here, things are changing, and certain results are being established. And what you're looking at are actually two results which we never talk about in our curriculum. So we do talk about Pythagoras theorem, but we do not talk about Pythagoras theorem for regular polygons. So here the regular polygon could be an n-sided polygon and could be 5, 8, 12, 50 even if you want. And just by a change of slider, you can demonstrate and verify the results. And you can ask children to maybe generalize them. And then also certain geometric wonders, which the ruler and pencil or a compass kind of a construction doesn't allow. So for example, trisection of an angle. So that is not possible, but with a GeoGebra kind of an applet, you can do that. So again, since there was a group of teachers who were from the who were teaching 11th and 12th, abstract concepts of pre-calculus and calculus. So when you are looking at trigonometric functions, we talk about trigonometric functions graphs. We talk about how the point moves around a unit circle, and then we talk about sine and cosine, and we have all the other functions coming in. But the task that you're doing on a piece of paper sometimes is overwhelming. The children are not able to understand what is happening. But with a software like GeoGebra, it would be just a matter of 5 minutes, and I'm going to make sure that I do cover this activity, and you will all marvel at how easy it is to get a figure construction where you are actually able to see the plot of trigonometric functions coming in. So these are all possible to explore. And as I said, it's all possible through the GeoGebra website. So if you still are interested in downloading, this is how you would go. You'll go to www.geogebra.org. This is the page that opens up. And then on the left-hand side, you will find something called as app downloads. When you click on it, all these apps will open up. I am recommending right now GeoGebra Classic 5 as an offline software for you to use. So you can download this and then join me as I start exploring more possibilities and doing some step-by-step constructions. Okay, so we'll come to Desmos, of course, later, but I'm going to just start with the GeoGebra. And just to save some kind of a bandwidth, I'm going to close my video and keep myself, of course, on in audio so that you can follow me along. And now I'm going to take you to the GeoGebra. What kind of a screen you get when you open GeoGebra. So for that, I'm going to just minimize this. So first, let's just focus on experiencing GeoGebra and see how that works. So let's take a look at, this is what your GeoGebra screen would look like. So when you click open the software, you would be able to see, if I just move this around here, on the top right corner, you can see a ring like an icon. That is the software installed on your desktop or under the programs. You will find this. When you double click it, you would be able to see a screen opening, something like this. So it's basically kind of a graph paper that has come up. I'm going to just make it a little bigger so that everybody can see the screen better, and I can then get started with it. So I hope now you are able to see this screen of GeoGebra. So this is how the GeoGebra software looks like. If you already have this with you on your desktop, if you have tried it a few times and have not gone ahead with it, and you still have the software, do open it, because I would like you to do this along with me, go step by step, and I'll try to be patient and not race through. So what you're looking at right now is just some graph. You have X and the Y axis. And then on this side, there is something called as an algebra view. So there is an algebra view, there is a graphic view. If I look at this little arrow, which sometimes, from distance is not that visible, but there's a little triangle on the right edge of the screen of GeoGebra. If I click it open, you will be able to see different perspectives in which you can use GeoGebra. So there is a graphing, CAS, geometry, 3D, spreadsheet, and also something for probability. If this is not visible in your screen, then you can go to view and you will find the same perspectives here as well. So you're looking at algebra, spreadsheet, CAS, graphics, graphic 2, 3D, and then something called as construction protocol, etc. If I want to work in a geometry, so I'm going by the number, we had so many of the participants teaching 6 to 12. So obviously you are teaching and not so much of graphs, but you are teaching more of geometry. You're talking about geometric constructions or geometry theorems. So how do we get students to understand geometry? How do we let them explore? So I'm going to now just change the view. So I don't want graph here. So what is one way of doing that is, one, you can always right click and you will get this kind of options open. I can hide the axis. I can hide the grid. Then I get a blank page. That's one way of removing the graph and the axis. Or you can go to view. So we were already getting those graphs and all, but if you go to just choose the graphics view, you would get also the blank page and there is no algebra view coming in. Because again, when we think about 6 to 10 standard students, we need to be a little mindful of how the students are working, because these tools that you're looking at here on the top, so take a minute if this is your first time, just play with these tools. These tools, if you click, say the first one with the A, that's a point tool. The moment my cursor is there, I hope you can see that it says select position or line. So it's called as a point tool. But point tool, how does it work is you can just select, so I can just mark it somewhere here and I can have that to be put. So I can look at this to be marked wherever. And as I plot these points, what you see on the left hand side is the panel of algebra. So every point has a multiple representation, and that multiple representation is coming in terms of as a geometric, as well as you're looking at the coordinates of the points. So with the younger ones, the coordinates of points may not be suitable because they don't understand ordered pairs, right? So if you don't want this to be visible to them, you can close it. But before that, let's explore other tools. So here, the next one, third from the left, is the line. So if I choose the line tool, then I can draw line just by clicking. Click and then click, not drag. Just click somewhere and then click. Similarly, here, if you look at the little triangle right at the bottom left of each of these tools, that sub menu opens up. So you have line, segment, segment with given length, ray, polyline, vectors, etc. So if I want to draw something specific, say only a segment, not a line, then I will choose the segment tool and I will be able to click and make just a segment. If I want a segment of a particular length, then I will click and then it will ask me how much length do you want. So I'll say, okay, 2 units, and I'll get a length of 2 unit segment. So that is a way that you're looking at each one of these tools behave. So take a minute, just play with them before we do any kind of a construction. The third one is for special lines, perpendicular line, parallel line, perpendicular bisector. So if I want a perpendicular line, then as you take the cursor there, it will tell you what you have to do. So it says select point and perpendicular line. So if I suppose want to draw perpendicular to this line that I have plotted passing through the C, then I'll click on the point C and I'll click on this line, then I will get a perpendicular line. And you will see that they will stay attached because the property, the moment I start moving this point C, this will remain perpendicular to the line that we had constructed. So the idea is that the conditions are what we had called as a dynamic applet. The property between this line and this line is maintained, although you can change the position of both the lines or the points. So that is the beauty of GeoGebra. And as we start doing a specific result, maybe we will explore more of these tools. So I'm going to just clear this screen. But before that, one small struggle that most of us at the first stage face is, suppose I have opened, activated the circle tool. So it is circle with center through point. So I'm going to click on, maybe I want this to be the center. So I click on that, drag, and I get the circle. Now I want to draw the line. So I said, okay, I want to draw the line, but the moment I click, I will keep getting circles only. That is because the circle tool is activated. So either use your keyboard to click on, press on the escape key so that you always come to the move tool. Or, you manually click on the move tool to get out of the earlier tool that was activated. So that is a small beginner's tip that I have given you. And now I think we are ready to do maybe 2 or 3 constructions, and maybe 1 or 2 from geometry and 1 or 2 from pre-calculus. So once I have all of this, do I need to save it? I don't think I need it, right? So what I can do is either I can select everything that is here and I can delete all of them. So I can have that as a possibility. Or what I can do is I can just close this file, and every time you work on a software, which is an offline software or even GeoGebra online, it will ask you whether you want to save your work or not. So in this case, I don't want to save, but what are the other options? I'll go to file and I will ask for new. So when I ask for a new file, it again asks me the same thing. Do you want to save or not save? So I'm going to say no, don't save. So I get my fresh page back. If you want to save, it will be saved as a file with the extension GGB. That's for GeoGebra. And you will need the software always to open the file. So we are now back to the fresh page. I'm going to do a geometric result right now. In fact, the one that you saw in the slides. And that is to build up an applet for the verification of the Pythagoras theorem. That is something that we all teach. So to do that, I need a geometry view, graphic view. So I'm going to click on the perspective and I need geometry. So I'm going to get a blank page absolutely here. So I have now a blank page, no distractions of ordered pairs or equation of lines or equation of circles or anything coming in. So I hope, I really have no way of checking with you right now, but in case there is, because it's not possible for me to keep track of the chat at this time. So in case you are unable to keep up with it, then I would like you to maybe revisit the recording later and see if you have missed a step or not. But starting from this point, We are now going to build up an applet for the verification of the Pythagoras theorem, and then extend that result for any n-sided regular polygon. Okay. So if you are all with me and ready, then we are going to start. So for Pythagoras theorem, what you need is a right triangle, first of all. And as you can see here, there are no such ready-made tools for a right triangle. So most of us would, when we are teaching students, we would maybe start with a segment. So we will have one side, which is going to be one side of a triangle, one segment of some length, because it's a generic result. So it's not going to be a length segment of a given length. It's just any segment. And now I want to get a 90-degree angle for a right triangle. So we know that there are some special lines here. There is one of perpendicular line. So I'll click on perpendicular line tool. And if you take your cursor there, it tells you how you can use it. So it says select point and perpendicular line. So I'll come to the point. Here is where I want the perpendicular to be drawn to this segment. So now you can see that there is a perpendicular drawn. If I want to test it, I will move it around, change the segment's length, move it around. You can see that they will stay attached and this angle is going to stay 90 degrees. So to get the right triangle, I can find a third vertex which will be on this line. So I choose the point tool and I mark it on this line. So I have three vertices. Now I want to get my triangle. I can again use the segment tool and join these 2 points to get the triangle, but I'm going to choose the polygon tool. So I'm going to choose the polygon tool, and again it says what do you have to do? Select all vertices, then first vertex again. So if I start with clicking here, then the second vertex, third vertex, and then back to the first vertex. That gives me my triangle, which is a right angle triangle. Now, what do you do with this line here? This doesn't look like the part of the construction. So in case you are coming up with the thought that you're going to delete it, then anything that depends on it will also get deleted. So in GeoGebra, we do not delete. Again, right click and you will see these options coming up. I'm going to click on show object, which would basically do the opposite of that. So it will hide the object. So the line that we had, perpendicular line that we had constructed is gone. And now I have a nice right triangle ready to use. When you're doing this activity with your students, it would be a great idea, especially when you are teaching children in grade 10 perhaps. You can ask them to suggest you different ways of getting this right triangle. So the discussion as the children work on it becomes more meaningful, because students have always a different way of looking at the things. Also with the juniors, when you give them a shape like this, many of them don't even recognize that this is a triangle. For them, everything that is a triangle must look like here. So if you're teaching junior classes, you can, have a lot of these sorting activities, or just simply when you're introducing basic geometric concepts, you can take a polygon tool and draw different kind of polygons and ask students to understand various characteristics. Also ask them to identify which one is and which one is not. Okay, going forward, I have a right triangle, and if I'm talking about Pythagoras theorem, then I would definitely need some squares drawn on sides of this right triangle. So to do that, if you explore further in the polygon itself, the sub menu gives you regular polygon. So I'm going to click on regular polygon. So my regular polygon tool is active, and now you will create a regular polygon on the sides of the right triangle. So I'm going to click here and then the second vertex. And now I need to, by default, it gives me 4. So we are happy to have 4 because we are talking about squares. But as you can see, the orientation of it has gone wrong. So all you have to do is not to worry in GeoGebra. You can either do Control Z from your keyboard, or there is an undo and redo points right on the top left, top right, which right now is being covered by, okay, I'm going to just remove this tool. So here is on the top right corner, there is an undo and a redo button. You can always use that as well. So what should be the order in this case will be this and this. If I click on OK, I get a square. Similarly, if I click on the point here and here, let's see if we get the right orientation. So again, it's gone wrong. So let's just say Control Z, and then we click and we get our square. Third square coming up again, and we have our 3 squares drawn on the sides of a triangle. And look at the beauty. As you change the size of the triangle, the squares drawn on it are also changing the size. Our intention is that students should be able to make a conjecture, verify, not prove Pythagoras theorem. So in order to do that, we need to get the areas of these squares measured. So similar to the activity that most of us do in the middle school, where we ask them to mark these squares on graph paper, and then we count the unit squares. We need the area. So to find the area of the squares, there are tools here. So under the angle tool, there is a sub menu, and there is something where you can find distance, area, slope, etc. I'm taking the area. Another thing which I would like you to explore is in the options menu, right on the top, you have file, edit, view, options. We are going to take this calculation rounded to 0 decimal places, because every software has some limitation. So if you take it in decimals, say second or third decimal place, you would realize that there's a little bit of inaccuracy coming in. So I'm not going to take chance with that. I've taken it to 0 decimal places. And now all I have to do is to find the area. I have to select polygon, circle, or conic. So I'm going to just come and click in the center of these regions, and you get a calculation of these. Now I want you to keep an eye on these numbers. What's happening? 26. Here I have 18 plus 9. There is an inaccuracy coming in, simply because there is a flaw in the software, in the sense that certain values are considered, or the thickness, or somewhere some inaccuracy does come in. So I always do this with the children, and I tell them that, see, when I rounded it up, I got a little bit of inaccuracy. Now I'm going to take it to first decimal place, and you check with me if this is now working out well or not. So you can see that that is now becoming more accurate, more true. And if I do this, I'm able to then establish the result for the students. So I am able to kind of make them draw conjecture that the area of the square drawn on the hypotenuse is equal to the sum of the areas of the squares on the other 2 sides of the right triangle. And the beauty is that this is not restricted to that usual activity that we do with the right triangle of, say, 3, 4, 5 sides. It's not restricted to one Pythagorean triplet. We don't even know what the sides dimensions are, but the result is still true. So this is definitely the beauty of it. You can, of course, do some cosmetic changes in terms of, how it appeals the students. So some kind of options in object properties can be chosen to give different colors to these 3 squares. So hopefully, I know it's very difficult to catch up from the long distance, but what did I do to get this, just in case you're curious? If I look at this top bar, this was hidden. If I click an object and I click on this little triangle here, it opens these graphic properties. In there, I can now change the color. So I can change the color of these objects and I will be able to get a little more appealing, and kids would love it. You would like to teach also with such kind of applets which are more attractive and more appealing to the students. So that is a simple visual verification of what we are looking at as a Pythagoras theorem. But what if I want to change this? If I want to get started with not just this, I want to extend this result and talk about Pythagoras theorem for regular polygons. Something which I showed earlier that it is not in your textbooks. But if you want to do that, then how does one do it? So I'm going to keep this here on this page only. And we are going to do another construction. So I'm again going to get a right triangle first, and I'm going to just give you another alternative method for that. So I have a segment. Now I need a 90-degree angle. So if you're teaching 9th or 10th standard students, they would know that angle in a semicircle is a right angle, right? So go to circle tool, look for a semicircle, and you click on these 2 points and you would get your semicircle. And now if you choose the polygon tool and you draw a triangle with 1 point on the semicircle and the other 2 vertices on the diameter, then we are sure that this is always a right angle triangle, irrespective of the size of the segment, right? And now again, the semicircle is the extra part, so I'm going to hide that. And now I have the right triangle. Same here, we did it in a different way. This is a different way. So definitely GeoGebra allows you to explore things in a multiple ways. And this is one of the possibility for you to try. Now comes the magical thing. How do I get that n-sided polygon? We saw that there is a way of getting a regular polygon, and it asks you for the number of sides. I want the number of sides to change. So whenever you want number of sides to change, then we take help of something called as a slider. So wherever a parameter is involved or needed, then we bring in slider. I'm going to click that and choose slider. I'm going to click on the open space somewhere on the page. Call this to be, say, n. And since we want our slider to start with the minimum value of a polygon, so 3, and it can go up to whatever number you want. So I can keep it to be, say, 15. And increment is going to be 1, because the number of sides are going to change to 3, 4, 5, and so on. So we have our slider ready. And now it's just going to take me maybe 3 clicks to get that fancy applet ready for you. What am I going to do? I'm going to go to the polygon tool and choose the regular polygon. Regular polygon, and I click on the sides, and I hope the orientation goes right. Now it asks me how many vertices do I want. So since I wanted to go with an n number of vertices, I'm going to type in n, not the value of n, the generic n. And I'm going to say okay. So do you see I've got a triangle? If I drag this n, then I will be able to see this changing. So I'm going to get now 3, 4, 5, 6, and so on. So that is as simple as that. We are now going to repeat the exercise for other 2 sides. So regular polygon, click, click, choose the number of sides and say okay. Similarly, click, click, and choose the number of sides to be n and okay. And I have that applet now drawn for 5. And then if I change this 5 to maybe 3, 4, 5, it will keep increasing. Now the last bit is to give a demonstration or a verification of the areas. So are the areas connected or not? So here again, the right angle is to be looked at, which is the right angle. So I can look at this construction and then think about how are these connected? So 7.6 plus 11.4 is same as 19. So do one verification, move and ask children to keep an eye on these quantities, or make a note on their registers and or notebooks, and or maybe give them a worksheet where they are exploring and making these kind of conjectures coming together. So that is the possibilities, with just a simple applet or a result which was restricted to squares on the sides, you have extended it to be something in the language of n-sided polygon. So again, I know, one-sided conversation can be difficult to follow, and also when it's a demonstration or an instructions of, step-by-step construction, it is possible that you have lost out somewhere and not been able to keep up with it. So I apologize for that if I have raced through some of the steps, but I'm also looking at the time that we have, and I don't think we would be able to cover too many things if I slow down. But just before I move on to anything new, I would like to definitely share that, GeoGebra is a great tool for distance learning, remote learning. So if you are in which I think all of us are in a situation where we are going to be teaching our children long distance, how do you see what they are doing? Right now, I can't see what you are doing. So in order to facilitate that, we have GeoGebra coming up with this fantastic update. So if you can open a new tab, and if you can, take this, maybe I'll try to put this in the chat as well. If I can try to get going with that and see where to find the chat. And then if you click that link, you would be able to then put this, I don't know how to put the chat in to all. Okay, so I'm going to put this link here, and I hope it would work and you would be able to join this GeoGebra classroom from wherever you are. So wherever you are, if you just click on that link in the chat, you will be able to come to this GeoGebra activity, and you will be able to work with me in this scenario and explore another applet. In fact, we might not even have time to do this right now. So once you're in the class, then you can keep exploring and I can keep watching long distance as well. But go ahead in the chat. I have shown, or those who are watching the YouTube live, even for them, you will go to geogebra.org/classroom. It will ask you for a code. You can put in this code and you will be able to join this room. Try that. I'm going to give you a minute to do that and see if we can explore another way of using GeoGebra with our students. Okay, so I'm going to give this a little time because people seem to be hesitating, but I hope that link is available in the chat and you will be able to join in. I'll check back the room in a minute. But in the meanwhile, let's do one of the, say, pre-calculus activity. Because I'm also looking at time. I don't think I'll have enough time to do many, but I want to also cater to teachers who are teaching grade 11 and 12. So let's see if anybody has joined. Nobody has joined in. What happened, Bangalore group? Okay, so once you have here, you're here in the GeoGebra. Let's try now something for the grade 11 and 12. So one of the concepts which I just demonstrated was the trigonometric functions. So if you're curious to know how to get the graphs of trigonometric functions, then to do that, again, we do need the graphic view. That is, we need the x and the y axis. And the definition of what you are looking at as the sine function depends on having a unit circle. So I'm going to now draw a circle So take a circle tool and I'm going to choose circle with center and radius. So if I choose circle with center and radius, center is going to be origin, radius is 1. I get a unit circle. So in this unit circle is where the entire trigonometry is basically happening. So in the unit circle, I'm going to now look at getting a arc angle and an arc. So for that, I'm going to take a specific point where this circle is intersecting the x-axis. Let me see if I can make it a little, sorry, zoom in. So if I can make it a little bigger so that everybody can see with me, and move this around so that we have things in view. Hopefully this is going to be better for it. Oops. So once you have that, I'm going to take a point, mark it where the circle and the x-axis are intersecting, and also mark another point on the circle. Just a small thing I want to share before we go further is that the point where the circle and x-axis are intersecting, that's a black point. Whereas this is a blue point, basically because it's going to move. That's important. And it should stay on the circle. It should stay stuck to the circle. Once you have that, then we are looking at getting an arc on this circle. So I'm going to go to circle tool, look at circular arc. Circular arc, it says select center and 2 points. So center is this, and I want arc to be from here to here. Now you can't really distinguish it, so I'm going to change its color. So make it red. I'm also going to change its thickness so that it becomes a little more prominent arc. So this is all I need. We know that if this arc is of the length 1, then the angle it will subtend at the center is 1 radian. If the length is, say, x, then the angle at the center is x. So I need the arc length. And the moment, in fact, I have constructed this, then in the algebra view, you would be able to see the arc length. There is a D, right? So this is something helpful for us. Now I need a point which is going to trace these trigonometric functions graphs. So to do that, if I go to view, there is something called as an input bar, which is mostly active, but because I was working in the geometry interface, so it had gone off. So view and then activate the input bar. Input bar is again, hopefully, you can see it, but it's going to open right at the bottom of the screen. That is where we are going to be able to type in something. So I'm going to type a point, coordinates of a point, and I want to get the sine function. So we know that we have defined sine x to be the to be the plot of the function which is going to give me the y coordinate of the moving point. So I'm going to choose an ordered pair, which is D, comma, and I'm going to write y coordinate of the moving point. And this moving point name, if I right click and I say show label, then that's C. So I'm able to now, again, let me see if I can increase the font size so that you can all see clearly as well. So here in the input bar, I'm going to type in D, comma, y coordinate of C. I don't need this line. So D, comma, y coordinate of the moving point C. If I press enter, that new point D has come up. Let's give it a different color so that it's a little more prominent for you to observe. So let's give it a purple color. Okay, so now is the main thing for you to do. If I move this point C, follow where this D point is going. Do you see that? The moment one full revolution is complete, D comes back to the origin. It starts again from the origin. So hopefully all maths teachers in the crowd know that this is going to be following that wave that we are understanding and accepting as our sine curve. For you to see this curve, right click, get an option, and there you will find trace on. And now when you move this point, you will find that the graph of this function is being plotted for one cycle from 0 to 2 pi. And then you can teach students the concepts that are coming up. Periodic. So we are talking about the periodicity of the function. After 2 pi, it starts repeating itself. We are talking about the maximum and minimum value, the wave-like behavior in the first and the second quadrant. So again, small adjustment to be done. Again, right click and go to the properties of the graph. So I'm looking at graphics view. If I go to the graphics view, I would like my X and the Y axis to be in terms of the multiples of pi by 2, not x-axis to be in the multiples of pi by 2. So I'm going to choose distance, and I'm going to choose what kind of a label or the units I want. So I'll be able to choose the pi, and I'm going to choose the units to be, let me see if I can make it smaller to see, pick that other graphic coming in. Let me just see. Okay, so I would be able to find, it's just a little enlarged, so it's not showing me the option on the other side. Give me a minute and we'll fix it, and we'll be able to then see how we can change even the labeling on the x-axis to be same as a pi by 2, multiples of pi by 2. So that is also an option that can be easily done. So I'm going to just reduce this for a minute and see if I can get my graphic view coming back to the regular size. So once we do that, you will be able to see that it is possible for you to get the construction done in a way which will be able to, when you enlarge or change the dimensions, something goes off. So I'm going to just get this back, and hopefully we'll be able to get the graphics as well in place. So here in the graphics, I'm going to change the x-axis. I'm going to change the distance to be a multiple of pi by 2, and there you are. So as you can see now, if I just make it a little bigger so that everybody can see, this is what it looks like. And now if you move the point C along, you will be able to get your entire 0 to 2 pi cycle of trigonometric functions sine. Similarly, we'll do for the other functions. So similarly, in the input bar, type in D, comma, X coordinate of the moving point. Moving point was C. So if I do that, I get the cosine function. If I take D, comma, Y coordinate of C divided by, if I am only getting the tan function, so I'm taking Y coordinate of C divided by X coordinate of C. Again, this is all happening in the input bar, which is right at the bottom of the screen. And then I'll have another point F. So as I move this point, you can see both E and F kind of moving fast, right? So let's give them some color so that they are easy for you to spot. So I have E point here. Let's give it another color, say red, and F point, let's give it another color, say green. And now when I also look at the trace of these to be plotted, you will be able to see the functions coming up. So I'm going to just move these around, and hopefully you can see the plot of sine, cosine, tan, all building up on your screen. And that is the those aha moment, as I call them. This is what is happening. You are able to explain the concept of trigonometric functions to the children, and in fact give them the opportunity, in fact, to create something like this on their own, and explore these concepts, figure out why should the curve why do we say sine function is going to be positive in the first and second quadrant? what is its effect of that on the graph. So if you look at this here, if I just hide these two, then you can have the discussion in terms of what is happening to the function as you look at the point moving in the first and the second quadrant. So in that case, you're looking at the function remaining in the above the x-axis. Then it goes below the x-axis. So third and fourth quadrant, sign is negative. This is what we have taught them. In various different ways, we have convinced them, but its effect on the graph becomes much more possible for them to explore through something as not as complicated, hopefully for everyone, but it is a very simple way of getting the result coming down. So let's take a look at if anyone has joined my class. Nobody has joined. It seems like something has gone off, maybe not working for you, or I'm not sure what is. But this was the link which I had put in the chat. So maybe it's giving you trouble to join in. All right, never mind. We still have plenty in store for you. So let's talk about the second thing. Looking at the time that is left, I don't think I have time to get into another applet of geometry in our calculus, because I also want to introduce you to the concept of what, or the tool, which is Desmos. So if anyone has already used Desmos, then I'm sure you are have been one of those who loves to explore and get new ideas coming in for your students. But what we are looking at Desmos is there are two things in Desmos. One, it's a graphing calculator. It is a graphing calculator. Basically, one would say, right, for the older kids, maybe the kids, students who are in 11 and 12. So yes, graphing is in our CBSE curriculum, more of the graphs and the functions concepts comes in the grade 11 and 12. So it is definitely very apt for that. But once you learn or use this tool, you will realize that it is something that you can, introduce to any age group. The other aspect of this is in terms of what we are calling as the um, uh, making the class into, or teaching maths in a gamified manner. So we are looking at students exploring maths through various activities. And I hope, to give you an experience of that as we go along. But before that, I want to just share how I have used Desmos in bringing, and not because now we are asked to look at art integration, but for years, I and my students have been using graphs to create beautiful images. So here is a way, and this is of course where my proudest piece, which a student had made in 2014 when she was in 11th standard, and now she is an engineer. And this is the school logo, Sanskriti school logo. And this has been created using graphs of functions which were not even taught at that level, but the child explored. So this is what Desmos can do. So Nayani is one of my student who did this, and she explored. There are almost 100 or more graphs with their domains restricted, as well as in some cases the range restricted. And this is the topic where we introduce them to this. So I want the children to understand the meaning of the domain, and want them to know that if you take a function or just a simple equation like that, but you restrict the values of x, it will restrict the way the graph appears. And of course, this is a brilliant piece, but many other pieces as well created by students have been a great way for me to see how they have explored the concept of using the Desmos to create this beautiful artwork. So again, one of my classic piece that I'm very, very proud of is by a student who did it in 2014 again. But even now, students are creating and using these functions to build up beautiful maths. So why again Desmos works beautifully is because it has a very simple to use interface. So if I show you a quick demonstration of what Desmos graph looks like. So this is the website for Desmos, desmos.com. Simple. Right in the middle, you will see a prominent graphing calculator button. If you click on this graphing calculator button, it opens up an interface for plot of graphs. Of course, GeoGebra does something similar, but GeoGebra has many other parts. Desmos has its own beauty and power. Beauty in the sense, it's the beauty is in the simplicity and the intuitive way in which you can use this. So if you are working with Desmos, all you have to do is look at this blinking cursor that suggests, and give it to the students. Students will not wait for you to tell them. They will plot. So the moment they put x in, you get a straight line. If I want this to be maybe x plus 4, it will shift. So we can have students doing a lot of explorations just by giving them this opportunity, giving them the way, go to Desmos and plot these functions and discover what they look like. So if I'm looking at the difference between a linear and a quadratic, so if I have x squared, how is that different from x plus 4? So that is typically what you are able to see right here. Or you want them to, like now we talked about sine function. So sine, and then within the bracket just sine x, and there you go. Not only that, the slider that we saw earlier. So if I want sine of ax plus b, and I want and sliders, I want for both, then I'm ready to now change the values of A and B, have the children explore the effect of A and B on the behavior of the graph. So A is the multiple of X, fact here AX. So as A changes, what's happening to the graph? So we can ask students to observe that. So we can ask students to keep an eye on how the waves are shrinking, and what will happen if instead of that, I had a C times AX plus B. So I add another third slider. So now let's explore what is going to happen to C times sine AX plus B. So if I change the values of C, is the graph going to shrink? Is it going to become enlarged? Or is it going to become high or low? So that is the amplitude that is changing, the maximum and the minimum values that are changing. Whereas here, the frequency in which the waves are falling is changing. So that is the kind of a discussion or exploration that you can do with a tool which is as simple as this. At the same time, as I said, you can have the beauty of this explored further. If within the brackets, curly brackets, if you just put the restriction that you want x to be between -4, and it is as simple as typing from your keyboard. So to get a less than equal to, I use the sign less than, then equal, and it became intuitively that x, and I want this to be less than equal to 4. So now my graph is going to be restricted just between -4 and 4, because it's actually going up to the 16, right? So it is going to get cut off at that. So if you want to make a face or a U shape, just like that, it's instead of that entire x square with the domain to be all real numbers, now it has become a function with a domain as -4 to 4. So that's again a very easy to use. And if you are teaching grade 11 student, I will highly recommend that you tell children to use this, and also use this to create artwork. So when you go to the Desmos website itself, if you're looking for some examples or to excite your students, you will find, and this time they had even held a global math art contest, and you would find fantastic work done by students from all across the world. Or if you want to just show them something which is local, it's not something that you have done or the child had seen in the website, but I have some of examples of my students as well listed in my website, and I will maybe share the link later with the organizers, and they would be able to take you to this page, and you will be able to come and see the beautiful artwork of the students of my school as well, because it is important for us to excite the children and direct the kids to, trying out different kind of possibilities that students of their age are doing. So all of this beautiful artwork is created by students over the few years. And of course, these are the best of the pieces that I have saved, but they try some simple, but then they challenge themselves and create some most intricate artwork as well, which as a teacher, I don't think I can even match to any extent, but I'm happy to have them creating and, taking this forward. Uh, Before we, go further, there's another aspect of Desmos, and that is called the classroom activities. So again, when we are looking for ways to engage children, for them to get involved in their learning, it is important for us to give them these opportunities to try explore maths in a different ways. So Desmos classroom activities are something which you must try, and I hope you will try right now as well, in order to just get an experience. So again, a humble request to you, if you have a device where if you can type in student.desmos.com, just type in student.desmos.com. It may ask you to log in. If you don't want to log in, you can continue without logging in. But again, if you're using this for the first time, you might want to come back to it. So I would like you to maybe create an account, but sign in with Google or not sign in. Absolutely fine. Just type in these codes and you will be able to join into the activity. And long distance, again, considering remote scenario, it's a perfect way. Although this was the way that I used it even in a regular physical classroom as well, that they would work and I will go along with them and do the discussion. So giving you a few minutes, why don't you just type in student.desmos.com. This is the slide that's open, and it will ask you for a code. Give it a try, just join in, and I'll open the same activity here for you to see as to what I'm talking about. So as a student, you would be basically looking at going to uh, typing in student.desmos.com. I'm just going to move this bar here and come to, so go to student.desmos.com, and you will type in the code that is showing up. It will ask you for a code. So type in the code that I had just shown you here. That is U364FD. Please try that, and I hope I'll get some participants this time. I was very happy to see the Menti responses coming in. So let's see if you can. We have 10 minutes. If you can try two of these activities just to give you a flavor, you can always come back to these activities later as well. But if you can join in, then that would be fantastic. As a teacher, you will go to teacher.desmos.com when you want to create these activities or use the activities that are already available in the website. So this is kind of the interface you will have, and I will find the activity which I have just created for you to work on. And well, you haven't definitely disappointed me. I can see 145 of you have already joined this activity. And that's the power of technology. That is the power of technology here, where long distance, I can do the class and I can do it in an asynchronous manner, right? I have assigned it through the Google Classroom to the students. The student open the link and then they get started. Now, as they are working on it, the idea is I can see that there are 4 students right now here, all of them coming up here, but also because we don't want your names to show up, or even in the class, I don't want to call you by your name. I'm going to just click on this and, make you all mathematicians and scientists, so that there is no one to be called by their own name. Now you are all some famous scientists and mathematicians. In fact, when I do this with my class, I always tell them to note the name and then Google and think about, come back with some kind of a work that person is known for. So we have a Marim Mirzakhani right here. We have all the other Florence Nightingale, you have Carl Gauss, you have some of the familiar names in maths coming up. So it's a great opportunity to talk about even mathematicians. All right, so what is happening now? People are going on doing something, but what am I looking at? So as a teacher, what my view looks like, this is of course the dashboard, but as a teacher, my view, what it looks like is something here. So the first question was basically, drag the point to show how you are feeling today. So that is just a warm up for the day, right? So if you have responded, then I would be able to see your response right now. So I have 148 of you joining in. So don't worry, don't think too hard about how you are. And I can click on overlay and I can see the responses of all the group coming in one go. I guess there are now 265 students. I think this must be a record for Desmos itself, because there's so many of us in this room. I hope it doesn't crash, but it does have the power to take a lot of audience members. Now you can see it took a little time for it to process. I'm going to try to close other tabs in my device as well, so that it doesn't slow the system down. And you can see most of us, these red dots, I hope you can see them, they are in the first quadrant. So here, this is basically, feeling positive or great. And then I also have given them chance to write something if they wish to. Now that is just a warm up, but there's the maths happening. Let's talk about the maths now. So moving on to the next screen. So in the next screen, they were asked to watch a small video and then make an observation. So this is a video about where a man decided to fly using just the balloons. And then, what is the first question comes to your mind? So the students are writing, how far did he fly? Good question. Will the balloon soar up? Always fly high. Balloons can take us away. Can I try flying up? Sure, absolutely, why not? And which gas is filled in balloon? So very good questions coming up here. And when you do this with your students, I'm sure they will definitely start thinking ahead. Moving on to the next screen. So let's move on to the next screen. And right now you are working as a teacher paste. I can actually change this to a student paste. So I can, control, but I'm not going to do that right now because we just want you to experience. So the third slide or third screen is where the maths start happening. And the questions are asked. So you are asked to try something. So I can see the students working here. I can open up one by one each of the frames coming up and talk about how did you decide? What did you do? So you're looking at the student experiencing this, and then I can see all of them one by one. And now the student starts doing some maths. So it took 4 balloons to make the duck float. The duck weighs 56 grams. With one balloon, how many grams could you float? And that is where the maths start taking shape. So the lesson is called balloon activity. But somewhere at the back, I hope as you work, you will start recognizing that the lesson is about ratios and proportions. And the child is then gaining this, building up this understanding. And as a teacher, I have the chance of clicking on this pause button. So I have a remote control, long distance remote control with me. Everybody's screen will freeze. Teacher has stopped the activity or paused the activity, and I'll ask everyone to look up. So in this case, in the Meet tab or in the Zoom window, come back to the Zoom window, everybody, and let's talk what's happening to the maths here. So how did you predict? So I can always, right now I don't have your names, but I can say whoever is the Courtney Gibbons, unmute yourself and explain how you got this 25. Okay, I see Charles has written 50. So Charles, do you think you can convince the same, answer to the others? That is where the maths discourse starts happening. And that is where the child learn along with the others as well. And I can, of course, unpause and get you going there. So again, looking at the time, I don't think I have enough time to take you through, but this is still on. Go ahead, do it. And if you are a teacher who's teaching 11th and 12th, just take a picture of this screen that's coming up, screenshot, and go to student.desmos.com later and type in this code. And I would like to share this activity, which I always use when I teach continuity of functions to the students. So I would love, for you to try this and see if this would help you to do it, with your class as well. So definitely there are plenty more as far as Desmos and GeoGebra is concerned on their website. And GeoGebra itself has a lot of activities on its website. So if you go to geogebra.org, go to classroom resources, and you will find all these applets which are ready to use by the teachers, even as an activity, which are as a classroom, which I have just now showcased, which once you try it, you will realize that long distance you can watch students do work, and you can also guide them, take them through the exploration and build up the mathematical concepts. So I think I need to stop here because I have exceeded that 25 or 25 time at this point. So thank you so much, everyone, for being here, for being your patience, and hopefully you have been able to keep up with what I have done. Maybe it was a little too fast in between, but I think I was running out of the time. So sorry for that, and I hope you've got some ideas to try on and take this forward at your own pace.
Ms. Sangeeta Gulati, you are amazing. I think even for another 1 hour, our teachers will definitely sit and listen to you. I'm not a math person, but I was glued to the screen. I'm here from the time you started. I'm just watching the way you are teaching. It is so amazing. And I was going through the chat, how the praises, the way of motivation that you have given to them to take up this challenge. And they're all full of praises for you, and we are really so happy to have you today. And I'm sure teachers have learned a lot. I think there are a few questions to be taken. May I request Vamshi to take up the question on behalf of the participants? Vamshi is the principal of MVJ School. Vamshi, over to you.
Manila, as I see right now in the Facebook, I do not have any questions, except as you rightly mentioned, everybody is applauding ma'am's presentation and the way she took us through. Geeta ma'am, over to you. In case if you have few questions which have been jotted down, you can go ahead.
Thank you, Vamshi. I think the session was truly amazing. And I think the participants were so busy praising ma'am that they have forgotten to put up any questions. But I just have one question which has relevance. One question which says, can these activities be considered as a part of art integration in mathematics?
Absolutely, absolutely, definitely. In fact, I would encourage each one of us to use it so that, we ourselves also come up and share with ideas as to what can be, what is working best. So you can have art integration done using Desmos, as I showcase, absolutely, or even with GeoGebra. So it's the same kind of task, just using circles. So if you can ask children to just using circle, create some patterns. So if you are teaching grade, the middle school, say 6th and 7th, so ask them only using geometric shapes, create a rangoli, use reflection, transformations, and create rangoli, because rangoli is a beautiful piece of art which has so much of symmetry in it. So all of that can be created using the GeoGebra tools, because GeoGebra does has transformation tools of reflection, rotation. So definitely, absolutely, do go ahead and do that.
Thank you, ma'am. And just one more question. Can this be used for conducting online assessment in mathematics?
Again, Desmos, I'm not too sure how you would be able to grade it, but GeoGebra, there are applets where you can ask them to, maybe do some kind of a questions or exercises. But yes, it would be a yes and a no. It will be an assessment which could be maybe again, where you, again for the say 9th and 10th, where we are giving as looking at the multiple assessment kind of thing. So where we are asking children to maybe create a visual proof of a geometric result. So those can be taken into a consideration. But if you are looking at a problem question to be solved and then marked, then maybe not.
Okay, thank you, ma'am. That's all I have, Manila.
Yeah. For the participants, we have posted the feedback form in the chat box. Kindly fill up the feedback form. Once we receive the feedback form, you'll be getting the e-certificate. Now, may I request Vamshi to propose the vote of thanks on behalf of Bangalore Sahodaya.
Thank you, Manila. Pure mathematics is in its way the poetry of logical ideas, as told by Albert Einstein. Fun, visualize, create, clarity, engagement to active learning. All of this was presented by you, ma'am. I'm immensely thankful to our resource person, Mrs. Sangeeta Gulati, for her efforts towards anchoring a brilliant, beautiful, and engaging session of today. Ideas and elegance of explanation of everything, I need to mention my deepest sense of appreciation to our resource person for actively engaging, promoting us to participate, be it Mentimeter or be it Desmos, which was truly magical. Thank you, Sangeeta ma'am. I also extend thanks to all the staff members of Bangalore Sahodaya School Complex Association and helping us in organizing this online session. An event like this cannot happen overnight. The wheel started rolling weeks ago. Our thanks to Mrs. Dr. Vasanthi Tyagarajan, who I think made it so very important to have you here, ma'am. And Bangalore Sahodaya was really thankful to Vasanthi ma'am also to have made it possible. The wheel started rolling weeks ago. It requires planning and a bird's eye view for details. We have been fortunate enough to be backed by a team of proactive and dedicated staff of Bangalore Sahodaya School Complex, headed by Chairperson Manila Challo. In short, I'm short of words for their involvement and their willingness to have taken this completion of tasks beyond their comfort zones. A special mention to our chairperson, as I mentioned, Mrs. Manila, for being the catalyst that stimulated us to do our best and standing as pillars of strength. With a deep sense of appreciation, I thank our loving principals, coordinators, teachers, and all who are non-mathematicians who have still made it possible and have been seeing the excellent comments in the chat box. Thank you, dear teachers. Thank you, principals. Thank you, coordinators. And thanks to Srinidhi, who has made it possible, who stood as a backbone behind to make this event possible. Thank you all once again. Thank you.
Yeah. Thank you so much, Sangeeta, once again.
Thank you so much. Thank you.
And thank you to Vasanthi ma'am for thinking of me. So I wish all of you the very best.
Yeah, she couldn't be here today because she's taking a session now.